the 8th of 10 conversations in which the late Dr. Jacob Bronowski related to George Steedman his personal account of the discoveries and philosophies of the 20th century. Last week, Dr. Bronowski described how physicists turned from physics to biology and unravelled the structure of the stuff of life. This week he considers evolution and suggests evolution is progress. Dr. Bronowski.
After 1945 to 1950, people began to take a healthy interest in nucleic acids. And they discovered all kinds of interesting information. It was pointed out, for instance, that the nucleic acids are made up of sugars and phosphates for structural reasons, and otherwise of 4 main kinds of really rather small molecules, none of them containing more than 12 atoms. And that these 4 molecules, as it were the letters of the alphabet, shuffled about in different ways, made up the nucleic acid. And there were pairing rules as to how much of one would go with another. Secondly, the information was carried on 2 parallel strands, and what was written on one strand was always matched on what was written on the opposite one. So the information was duplicated. This lent itself particularly to understanding how it would work when a cell divided, because it then became clear that the 2 strands would take apart. One would go into each half of the cell to make a beginning for a new cell, and would there form on itself a parallel match. So we had a duplicating process, a little like a chain reaction. Well, it was a beautiful time, because it suddenly showed that biological phenomena could be described in very simple terms, that there were very exact physical and chemical relations which determined it. It showed that the language of life was universal in that every cell was given its special properties by exactly this same thing, a particular DNA that said, this is an elephant, or this is a rose, or this is a banana. What was said by Francis Crick and James Watson once for all is, all life has a special character, all life has the same special character. It is made up of quite ordinary atoms, but it's alive because the atoms are arranged in an architecture which lends itself to reduplication and therefore to the carrying on of life. So that's the definition of life. When is a thing alive? When every moment of its existence repeats a process which ultimately will be handed on from it to its offspring. And the architecture of DNA is a physical structure which shows just how this happens, both when a cell divides and when cells unite to form a future creature.
There's a new paradox in the state of knowledge about the physical nature of life now. We were brought up to believe that the second law of thermodynamics was absolute, that if you left systems alone, they ran down into randomness. And yet, your pure physical system of life, with its organization, winds things up into order. Do you accept the jokey definition of life as negative entropy?
Like all jokes, it contains the most serious truth. And like all jokes, it has to be turned into a joke because the serious truth is so difficult to explain. But you sort of kicked me into this subject with that initial joke, and therefore I must take it up. The physical world in general runs down. Any orderly state becomes less orderly as time goes on. It's clear the biological world is different. disorderly matter, or matter of very low organization, is built up into more complex systems. For instance, the breakfast kipper that I ate earlier today can be demonstrated to be, in many respects, a somewhat simpler form of life than mine as a human being. I am, in an evolutionary sense, a later and more complex animal. So I feed on the kipper builds me up, and not the other way about. How does this come about?
Of course, one of the ideas in the center of our skulls that we inherited from the 19th century, that we have to admit was there when our century started, is Darwin and evolution.
Just so. We ought to start with the simple ideas of evolution. Life is made up of the same atoms that non-living things are made up. It differs from them only in its architecture or organization.
Its pattern.
Pattern, organization, complexity. So that in a sense, the idea of an evolution of complexity comes in from the very moment you realize that life has this special pattern, which in the higher animals becomes more and more complex. How did it begin? Well, it begins in the first place, we are not in much doubt, roughly speaking, 3,000 million years ago, in certain quite small molecules, like hydrocyanic acid, for instance, which are capable of taking part in processes in which the same product is formed over and over again. Just as we as animals are made up of individual cells, so all through life, a simple basic unit replicates itself and builds up more complex structures. That's a fascinating and very new subject about the early beginnings of life. What we know about it is deeply interesting but very speculative. My colleagues at the Salk Institute work on it very hard because it's such a beautiful subject. But I won't say more than that. The simple beginning are molecules which we now know to be floating about in outer space, formed from hydrogen, carbon, nitrogen, sometimes some oxygen, which are capable of reproducing themselves in the same pattern. How we get on from there to nucleic acids and to cells is a very difficult problem, very little understood.
In the 3,000 million years from
in the 3,000 million years, or in fact in the first 1,000 million years, by the end of which cellular animals were...
You can find them and identify them.
Yes, were traceable. That's one of the big gaps in our knowledge. It's really a very big gap between 3,000 million years ago and 1,000 million years ago. But after that, particularly after 1,000 million years ago, when for the first time traces of sexuality appear in animals, and evolution begins to go faster.
I wonder if most people understand that remark.
Well, it's a simple idea, and I should have explained it, yes. If a creature duplicates itself simply because its cells divide, then the tendency is for the cells to be identical copies of the original. But if a creature has a male and female forms, and the male and female must conjoin, have sexual intercourse, and form a new cell, then that cell will carry some properties from one parent and some from another, genetic properties of the kind first discovered by Mendel. And of course, that makes it a creature with much more potential than one which had only one parent.
Well, it has more individuality, more potential for disaster or success.
Or success. And you see, nature doesn't care about disaster. The disasters are thrown away. Nature just preserves the successes. And one success is worth 1,000,000 disasters. Nature works on that generous scale of continual bankruptcy in order that a few, as it were, millionaires of evolution, richly endowed creatures, shall emerge.
How, in this picture, we now have that your variability is being mediated by a now recognizable material such as DNA in the human species. How does that change the view of evolution, of the evolutionary nature of man, from what it was, say, about 1880, when Darwin had been assimilated and Bergson was talking about the élan vital, the creative life force of evolution and so on?
Bergson was quite right in understanding that evolution is the one creative process which nature carries on. That we must never lose sight of. I'd like to put that in a simple analogy which is well understood by biologists but not well understood even by physicists. If you and I were sitting here talking about the physical world, and we were sitting here 50 million years ago, we would say, well, crystals are made in the following way. And crystals have certain properties if they have faults in them, which give them a special character. Perfect crystals are weak, imperfect crystals are strong, we would say to one another, and we would nod sagely, and if we wished we would explain it to our hearers in greater detail. But if you and I were sitting here 50 million years talking about monkeys or human beings, we wouldn't be talking at all because there were no monkeys or human beings 50 million years ago. You see, in the last 50 million years, the biological world, as a result of evolution, has changed radically. The physical world, not at all. The physical laws, not at all. Biology is a historical science. What you and I are saying now will seem terribly old-fashioned 100 years from now, and will simply seem wrong 1,000,000 years from now because far more intelligent creatures will say it without the aid of all this metal apparatus that we are using, and we shall be heard 5,000 miles away by our descendants and theirs, again without all this apparatus. Evolution is creative. Life is historical. And science in the second half of the 20th century is a historical science because it's concerned with biology.
We said that when the atom bomb went off, the first experimental bomb, one of the physicists, I think Fermi, said, there goes the end of a beautiful subject. There are people already who say it is leading to the creation of molecules which can be interjected into life and make it cease to be a beautiful subject.
Well, you're rushing into pessimism rather fast. And as you know, I am by nature an inveterate optimist. As evolution progresses, it not only produces more complex creatures, it actually produces more complex processes, and sex is one of them. I want to talk about the evolution of complexity because that's the answer to your question about entropy. Why does life climb up when most of the universe runs down? One ought to start with the building up of any complex structure. A more complex molecule from a simpler one, a more complex atom from a simpler one. When in a star helium is made from hydrogen, why does that happen? It happens because although hydrogen is a good raw material, helium is a conjunction of hydrogen atoms so closely fused that it's actually more stable, and itself becomes the raw material for new atoms, of which carbon, on which all life depends, is the most important. Now, that has happened with all living structures. First, things like the amino acids and the nucleic acids. Second, the cell. Think of the beautiful invention of the cell, which started much over 1,000 million years ago, and for ages didn't form very complex creatures, and then nature discovered the trick of putting cells together so that they all have the same equipment, and yet some of them decide to be a nose, and others decide to be an eye, and others decide to be an ear. And you could transplant them and make them be the wrong thing in the wrong way. Some cancers are of that kind. How does that happen? It happens because of that Platonic thing, which is that several simple units put together make a structure which is more stable, more self-organized within itself. You had a beautiful instance of a smoke ring which is more stable than its individual atoms. And all living things have this quality, that there is something about the way that they have been organized which gives them a resistance to disturbing forces which the individual atoms didn't have. Why does a smoke ring hold together when you blow it out of your mouth? Because as a whole, it resists the wind better than the individual atoms in it would. Why does a multicellular animal resist the disturbances of nature better than a unicellular animal? Because it is not buffeted about by fate, climate, hot flushes, cold streams, and so on, in the way in which individual cells are. And it's that advantage which a collection of cells takes, and which a more complex animal has over the simpler animal.
And in your very simple piece of physics, when the hydrogen atoms have been knocked together to form helium, helium doesn't burn and hydrogen does. It's not inflammable.
That's right. That's right. And helium now becomes the new raw material, the new building block for more complex atoms. There's a very beautiful analogy here, in fact, to the way we organize all our intellectual life as well. Dots make a letter, letters make a word, words make a sentence, sentences make paragraphs, paragraphs make chapters, chapters make a book. And that runs through our social organizations, our city structure, and the like. There's obviously something very deep about the laws of nature, which you began by calling negative entropy, namely, that complex things hold together by virtue of their organization, even though their simple units are the ultimate building blocks to which they would otherwise fall. The difference between non-living things and living things is contained in that paradox. In the non-living things, the cohesive forces are not very powerful, and the passing of the years breaks down the pyramids and everything else. But in living things, you have formed a continuous structure which is stronger than the pyramid. I'd like to finish with the example of the pyramids. The pyramids are falling to pieces. The men who built the pyramids are already dead, but their descendants are the very guides who are taking others over the pyramids today.
And their faces are the same shape.
Yes, because they gave to their descendants a structural persistence, the quality of a smoke ring, which persists through time and reduplicates itself, and that's the nature of life.
That was the late Dr. Jacob Bronowski in a conversation he recorded with George Steedman.